Okay, everyone, fantastic, great. Well, thanks so much for joining into this webinar. So once again, my name is Kevin Hansen. I'm a solutions architect with Tengen, and I'm here to talk to you a little bit about building your first application on top of MongoDB. Actually, that's what I do as a solutions architect, is I work with customers of Tengen and members of the community, all who are using MongoDB to help them get up and running, and help them build their applications and kind of transfer that shift of mind where we're so used to working with relational databases and how they lay out data models to working with something a little bit different, like MongoDB. So, first of all, what is MongoDB? Who am I? What is Tengen? So, MongoDB is an open source, high-performance, document-oriented database. And it is built and supported by Tengen. And so Tengen is the company that I work for. Tengen is the company that builds and supports MongoDB. We write all the code here. So we store our documents, or actually we store our data as documents, and it's JSON, or BSON is our storage model. So JSON is JavaScript object notation. So for those of you who are familiar with it, it looks very simple. It's human readable, nice and easy to look at. You just look at it. It kind of looks like XML, but more simple. We've actually extended that type to what's called BSON, which is a binary serialization of JSON. And we have an open spec for that, and we've published it at bsonspec.org. So you can check that out. I mean, if I had to summarize it, the basic thing is that we add support for complex types and dates and things like that. The other big differentiators of MongoDB is that we have indexes, secondary indexes. It's not just a key value store where you're querying on some primary key. Just like a relational database where you can query on any number of columns, in Mongo you can query on any number of fields. And we have a full query language that comes with the database that helps you leverage that. The other thing too is it's really been taking off, and we see now downloads of around 150,000 downloads per month now. People are downloading Mongo like crazy, and it's really starting to take off in the enterprise especially. And one of the reasons for that is it's so easy for developers to pick up. If you haven't used Mongo before, you can probably just try it while you're listening to my presentation right now. Just go to mongodb.org, you download it, unpack a few files, up and running, boom, you can load files, or you can load data in there and you can start querying it, etc. So check out, if you're curious to hear more features, you go to mongodb.org, and we have a good overview video at tengen.com/whatismongodb. That's sort of step one, right? What is Mongo at a high level? And we'll jump into some of the kind of features and more specifics in a moment. But I think the first thing is to stop thinking relational when it comes to the data model. And that's what I'm talking about, the data model specifically. We're so trained, I think, to kind of think about how do we normalize this data, how do we do it so that the addresses are represented in one place and those join out to a table of names and the names are represented there, and we want to kind of have all these categorically represented, and we spend so much time on this. I think with Mongo, one of the first things you want to do is, instead of thinking about it in that regard, think of your data as far as how the application wants it. If your application is asking for data formatted in a certain way, consider storing it in the database that way, and rather than having to join data together when you bring it back out. And in many ways, that's easier for us as application developers too, because when we store a piece of data in a database, or when we store a piece of data that is application code, which is an object, we expect that object to be stored as an object often. We don't expect that to have some mapper then map that to a relational database underneath. So really, it's not only how the application wants it, it's in many cases stored how the application developer wants it, which makes it so easy to pick up and easy to use. The other thing too is the data model. So not just that it's not in terms of rows and columns, but it's JSON or BSON documents. So if you look at this little sample document here on the right, it's much more simple and easy to read than a series of tables. The first thing is that it's self-describing. You can read the document and you see what it is. Title, MongoDB, contributors, etc. You could actually think of these as a set of key value pairs if you want, but instead of just key value, key value, key value, where the value is a constant, think of it where the value can be either a constant, it can be an array, it can be another document inside of that larger document, and you can you can nest these things. So in this case, your contributors is an array of 2 sub-documents, and each one of these sub-documents is a contributor. So there's parallels, though. So, you know, it's important to kind of break your mind away from thinking about how to represent data in terms of rows and columns and tables. But that being said, it's not that they're not comparable. Every database is going to store some number of records. Right? The whole purpose of a database is to store records and to query and retrieve records. In a relational database, those records are rows. Rows are the lowest level of data that you can get, a single row. In MongoDB, those records are documents. So we've got rows and documents which map together quite well. And then in a relational database, a bunch of rows that represent the same data goes inside of a table. A bunch of documents that represent the same type of data are going to go into a collection. So there's a parallel not only between rows and documents, but some number of rows make up a table, some number of documents in MongoDB make up a collection. Now, in a row in a relational database, every row has a bunch of tables, or I'm sorry, a bunch of columns. So things end up looking kind of like an Excel spreadsheet. With MongoDB, like we just found that last example, instead of having columns in there, we have sets of fields. And the difference is that we can nest these so that you have a hierarchical data structure rather than one which then is going to, if you want depth, have to join out to another table. Indexes are relatively the same. We use B-tree indexes, so properties that you're familiar with when it comes to relational database indexes are very similar to those properties in MongoDB. So being able to declare an index on a specific column is not that different than declaring an index on a field in Mongo. Now, joins are one thing where there's not a direct parallel. So because of our data model and because of how it works, this data model is, by default, taken out of this normalized relational data model. And so then we don't do joins. So you can either embed documents inside of each other. For example, if you had a blog post, you could embed comments inside of it instead of linking out to another one. And then you can also link documents. So linking documents is actually very similar to a join in a relational database or a foreign key constraint, except that it's not enforced at the database level. So that's something at the application level, you are going to basically have an app-level join between these two documents. So it's 2 separate queries. One document to get the first document and to get the value inside of it, and then another query to query the other collection, which then you're querying on that field. The other thing where there's no parallel is in terms of a schema object or a schema in general. So MongoDB is a schema-less database. What that means is that in any collection, you can insert documents that don't all look the same. So if we had a collection of users, and for some users we had hair color and birthday, then we would have hair color and birthday fields. And if we had another user where we were tracking shoe size and T-shirt color or something like that, then then we would represent those attributes where they existed, but you wouldn't represent the data that doesn't exist. So you don't need to have the same schema. They can all look completely different from a database perspective. Now, of course, that's not a desired output. Every application has some type of schema. You want documents to look similarly, and so that schema enforcement is brought out to the application level. So here's another example of our data model and looking at our rich documents here. So one thing to take away is that it's an example of having nested documents inside of an array. So this is a blog post sample right here, and you can see that with just a single document, we can represent this blog post. We've got the author, Roger. He's represented directly in there. In a relational database, you'd probably join out to another table for Roger. We've got our date in there. You've got a bunch of tags. And then we have the comments for the blog post as well. And those have a different author field. That's the author of the comments. But you can all have it nested nicely inside of one document. And there may be reasons you may want them nested, or you may want them in a separate collection, but those are sort of application-level schema design questions that are a little bit deeper. But the idea is that it's flexible and that you can represent the data how you'd like it to be represented. So another thing is Mongo has, like I mentioned earlier, a really rich query model. First of all, you can query on any field in any document. If you're querying on a field and that document doesn't, or that field doesn't exist in some documents, then you just won't get that result, that document back as a result. but you can query on any field. And it's not SQL, right? It's not the structured query language for relational databases, but there are some parallels. In fact, they're quite similar. If you just look at that first query on the top there, db.posts.find, you can think of that as select star from table posts. We're basically just bringing back all the documents inside the posts collection. What's a collection? It's like a table in a relational database. The other thing too, you'll see that we have that underscore ID as the first value. So that's unique, and that is unique enforced by the database. But you can have it be anything you like. So this is kind of like a primary key for documents, and if you're not specifying one when you insert it, then we'll automatically generate one for you. Or if you like, you can specify your own set of underscore IDs. So MongoDB also, I mentioned this earlier, has the ability to support secondary indexes. So that's great. It's not just a key value lookup where you're looking up everything based on some kind of primary key. You can create an index on any field in a document, and you use that command db.posts.ensureIndex. So you see that command there, db.posts.ensureIndex author1. So author is the field that we want to index. So we're going to index the author, and the 1 means that we're going to put an ascending index versus a descending index would be -1. It doesn't typically matter if you do ascending or descending, except in the case of a compound index where you're doing a single index on 2 fields. You might, for example, want to put a compound index on an author name and then a post date. So in that case, then it would first sort by author name, and then in the case where the author is the same name, you'd have that one ascending, and then post date descending would then put for where all the posts are the same author name, give me newest post first. So that's an example where you might, want to use ascending or descending. And then if you just look at basically the command, then we run the command there to, to ensure the index on author, and then we run a query on author Roger. So just to bring that back. MongoDB has profiling tools, so you can go and check and see, is my query using an index? If it's not, why is it not using an index, etc. So you can run explain plans at the end of queries as well. So if you run db.post.find, you run this query .explain, MongoDB will generate a list of basically how that query was resolved and basically help you performance tune your application. You can also put indexes on nested documents. So that would be if we go back to our example of this blog post over here, where we have author Roger of the blog post and author Fred of the comments. We can use our our indexes on nested documents to basically index step down inside of these documents and put indexes on them. So that's great. So you can basically have a separate index on the author of the comments and a separate index on the author of the blog post. You can also index tags or multi-key indexes. This is essentially putting an index on a tag so that basically if you query for any of the values in that array, the document will be returned as a hit. So instead of just basically having one big value in the index, you have one value for every element of the array. We also have geospatial indexes. And actually, if you've used Foursquare before, then you've indirectly used MongoDB. Foursquare runs entirely on Mongo. So this, when you declare an index here, db post ensure index, you just specify it's a 2D location, and you can put it on any 2 values, whether it's an array or the first 2 values of a document. And then we're running a near query here. So when you check in someplace on Foursquare and you say, okay, I'm here, and they're going to return you back a list of places that are nearby you, that's essentially running a near query in MongoDB to bring back the data that's close to you. So if you're using Foursquare, they use Mongo. People also use the geo indexes for things a little bit less complicated. I mean, you can use them for something as simple as tracking 2-dimensional movement on a checkers board or a chessboard. The other thing, too, is we have atomic operations, and that kind of gets into the whole transactions and what does that mean in a non-relational database or a NoSQL database. So, so if someone could mute their line over there. So we have these atomic operations, and what these are these essentially transactions, but at the individual document level. What that means is that when you insert a document into Mongo, that document is either going to be fully inserted into the database with all of its indexes built, or it's not going to be in the database. Right? So it's either 0 or 1 in the database or not. So it's transactional at the individual document level, just not at the 5 document level. You can't commit 5 documents in Mongo all in an individual database level transaction. And then in terms of updating things, in Mongo, we do in-place updates, which is a big differentiator for most of the non-relational databases. And what that means is that if you're just incrementing a single value or you're just making a simple change, then then we're going to go down to that individual document and we're going to make that change rather than basically inserting a new document and then expiring the old one. So that kind of model is called multi-version currency control. We don't do that. We do in-place updates. And there's all sorts of atomic updates that you can do. So for example, you can push to an array, you can pull from an array, you can set values, you can increment values, you can unset values, you can add new fields, you can remove fields, etc. And you can do all of that atomically. So step 3 here is building a sample application. So let's kind of walk through the data model for this. But actually, before I do that, I want to see if anyone has any questions. You can just type them in the chat room. And if you have some questions, I'll answer a few of them. Here, let me just pull up this chat window. So if anyone has any questions, you can just type them into the chat window, and I'll take a moment here. No questions? Okay. Okay, so one person asked, I don't know if I missed it, but does Mongo run as a server? So yeah, I mean, when you run Mongo, it actually is a single process called MongoD, and MongoD is a daemon that's going to run in the background, and then you can connect to it with the Mongo shell. So when you download MongoDB and you want to run it, it's the MongoD process that's going to be running in the background. And we typically recommend that you deploy Mongo on its own machine rather than kind of sharing it with app servers and things like that. And then someone asked any quick deployment tips for Amazon Web Services. So with Amazon Web Services, actually Foursquare runs entirely on Amazon Web Services. I just mentioned Foursquare, and a lot of our users use AWS. I think the only things to be aware of in that case are the things that you always need to be aware of when you're using Amazon Web Services, which is, well, you're going to have slower disk performance because you're likely using EBS, and EBS is sort of unpredictable. So actually, if I had to give a quick advice, it would be try to have most of your data there retained in memory. So basically, as much memory as you can. Mongo uses memory mapped files, so it will keep that stuff in memory because the disk performance is going to be the big limiter with using something like AWS. The other thing, too, is that I think that the way Amazon provisions machines is that you buy like small, large, or extra large, and that comes with memory and CPU. But I would say in general that Mongo is more memory intensive and not so CPU intensive. So if you just get the machines with more memory, that's what you would want. Someone asked if you could use Mongo to sync data between apps similar to iCloud. I mean, you absolutely certainly could. And the way that you'd be doing that is that you would be building a Mongo web service or a web service on top of Mongo that would basically then take user data, persist it into MongoDB, and do so with a timestamp and things like that. And then when you're looking to retrieve or sync data, based on whatever that business logic is, i.e. give me the most recent data, give me the data that is the person's rolling back to, etc., you can pull that out. And then someone wrote, can you simulate a transaction with the atomic operators? So yeah, you absolutely can. It is basically transactional at the document level. The only thing that it doesn't do right now in terms of transactions is the ability to roll those transactions back. Right? So in SQL, you can commit 50 documents, you can roll them back, etc. I mean, yes, we have plenty of tools. There's an op log that you can go through, and you can look at transactions, and there's so many things you can do, but there's no just sort of roll back, click functionality in Mongo. And someone asked, is there a .war version for easy development or easy deployment? Actually, I'm not certain off the top of my head. So, I guess Google or something, because I don't know about that. So let's kind of, and I'll ask for more questions in the end, and we can go through them. But actually, if you're shy and you have questions, feel free to email me. My email is kevin@10gen.com. So that's KEVIN@10gen.com. So feel free to email me. And let's kind of walk through now what the data might look like for a sample social media check-ins application. Something like we were just talking about Foursquare, something similar to Foursquare, but obviously much more basic. So the first thing that we need to think about is what kind of data are we going to be storing in this application? Well, there's really three kinds of data. We need users. Oh, did someone just unmute their phone? Just mute it back if you did. Okay. So, hello? Okay, there we go. We're good. Okay, so we need three kinds of data. We need places, so places where we can check into. So if you think of Foursquare, we need airports, we need restaurants, we need all those. The other thing is we need people, users. So users need to check in. And then we need to store where everyone checks in, so all their check-ins. So every time somebody checks in someplace, that will be a check-in. So we basically need three collections: places, users, and check-ins. For places, what we want is we want to be able to add user-generated content. Things like quick tips, geolocation, any other tags that might come up, we want to be able to add those to our places. And what we want to do is then we want to ask simple queries, i.e., here's my current location, answer, give me the places that are nearby. So let's look at our place here. So if we want to insert a place, this code right here, this will actually execute in MongoDB's JavaScript shell. So I mentioned, how easy it is to get up and running with Mongo. Basically, what you're going to do is you're going to download Mongo, unpack it, and then you type the command MongoD. MongoD is the MongoDB daemon. And then in a new tab, then you just type Mongo, and then Mongo is the shell that will connect to MongoD. And it's a full JavaScript shell, so if you were to write this right here, it would work correctly, and it would save this document into our collection of posts. So you see that collection there, db.posts.savep. Actually, that's a bit of a typo right there, because instead of posts, that should be a collection of places. Actually, let's fix that. db.places. There we go. So now we've saved this place into the database. It's got a name, an address, a city, a zip code. We can add some tags. So we can tag it as MongoDB. We can tag it as a business. We can give it some latitude and longitude. And then we can have user-generated tips. So as we add these tags here, the tips are probably going to constantly be coming in. Someone checks in, they add a tip. So Kevin might say, stop by for office hours. So how do we add these tips? We'll use this right here, db.places.update. So this is one of our atomic updates. Someone had asked a question about them here. And the way it works is you just specify two parameters. The first one is you specify the parameter that you're looking to find for the document that you'd like to update. And the second one is what's the operation you want to do. So the first parameter here is name 10gen headquarters. And the second parameter, and notice these are all done with JSON documents, right? The second one is, okay, we're going to do the push operation. We're going to push to an array. We're going to push to the array tips. And then inside the array of tips, we're going to push a document written by Nosh on a timestamp telling people to stop by the office hours, or stop by the office for office hours on 4 to 6, or on Wednesday from 4 to 6. So how do we query our places? Well, the first thing we need to do is we need to create indexes. Every time you want to create indexes, on any field you're going to be querying on. So create as many indexes as you need, and then the rule of thumb would be also to create no more than the amount of indexes you need. The more indexes you create, the more space that's going to be taken up on disk, and also the slower your writes are going to be. Because like I mentioned, when we write something to the database, it's not committed until it's created with both itself as well as its indexes. So here we're going to add, what are the things that we want to query on? Well, we want to be able to query on the tags. We want to be able to query on the names of the places, and we also want to be able to query on the latitude and longitude. So the key thing to take a look at is just the notation, right? db.places.ensureIndex, and also for that final one that we are now specifying that is a 2D index. So if we want to find places nearby, then we just run that command, db.places.find, and then we specify lat long, and then we use $near, so that's the near operator. And we give it our location, and it will turn places closest to us. Now maybe we're a user and we're checking in on our mobile phones, and as we're checking in, we're typing in the name of the place that we're going. Well, in that case, then you can use regular expressions. So you can see here db.places.find, and we've got the name with some sort of type ahead string, so that as we're typing the place that we're going, our application can suggest what we're trying to type. And you can also query using tags as well. So now we've got our places. We've just discovered a data model that's going to work for places, which is all the metadata about a specific place, its latitude and longitude, and some user tags. Now we need check-ins and users. So, and what are we going to ask for these collections? Well, really, all we want to do is that we want to record every time a user checks in, and we want to record all of our users, and we want to get some statistics based on that information. So, here's a user. We've got a user here, it's me, Kevin Hansen, with an email of kevin@10gen.com, and then we've got an array of check-ins. So you can see that check-ins is an array, and it has these sort of long numbers in there, these identifiers, and that is an object ID reference to the check-ins collection. Oh, whoever just, there we go, okay. So that's an object ID reference to the check-ins collection. So that's our users, and then we also have check-ins. And every check-in is going to be a check-in document with a place, a timestamp, and a user ID. So that's actually interesting to talk about, because you'll see here that this check-in references an object ID of a user, and we had a user before which referenced the object ID of a check-in. So we have these two things which reference each other, and keep in mind that's our application that's creating that. It's not some database level created foreign constraint or foreign key. But every check-in is two operations. So we're going to insert a document into the check-ins collection, and we're going to push to the users collection the check-in value, or to the check-in object ID to the users array. And so we can do some simple statistics with Mongo. First is that we can just say, okay, like db.checkins.find place 10gen headquarters. So with that, we're just saying, give me all the check-ins at the 10gen headquarters. db.checkins.find place 10gen headquarters .sort timestamp -1 limit 10. What that's saying is, bring me back all the check-ins at the 10gen headquarters, sort it by most recent first, and give me only 10. Finally there, what we can say at this one is we can say, okay, with timestamp of greater than midnight count, we can say, give me a count of all the check-ins that happened after midnight, i.e. today. So MongoDB also has a full MapReduce implementation. So with MapReduce, you can run these complex queries to do statistics and things like that across your data set. So you basically need a map function and a reduce function, and these are going to be written in JavaScript. So here's just an example of a very simple MapReduce functionality here, where basically what's going to happen is the map function is going to go and through all the places in the check-ins, or I'm sorry, in the check-ins collection, it's going to go, and for every place it finds, it's going to emit a 1, i.e. we're starting to count here. For every place that we find that's like 10gen headquarters, we're going to find something in the check-ins collection, we're going to add a 1, so that eventually what we do is we get totals of all the check-ins here. So then what we're doing is when we run this reduce function then, which returns the sum of those values. So if you look at this final command here, basically what we're doing is we're running a MapReduce job that's going through, and it's returning a list of all the places, a list of which places have the most check-ins within the past 3 hours. So the other thing too is that we have a new aggregation framework, which is going to be out in version 2.2 of MongoDB. So hopefully next month it will be out. And what that's going to allow you to do is it's going to allow you to do many of the same types of queries that you were doing with MapReduce, but to do them native to MongoDB. So no JavaScript layer that you need to go through. much more simple to express the queries, and because you don't have to go through JavaScript and because it is native to the database, we found that it's an order of magnitude faster than MapReduce. So this is an example of how to do these basic stats with MapReduce, but if you're looking at your application's use case and you think it's something where you're going to want to be doing some statistical analysis across your data set, we'd really recommend trying out the aggregation framework. So like I mentioned, that's going to be on 2.2, which is going to be our production-ready branch in about a month or so. But if you're interested in testing it right now, you can find on our website the MongoDB 2.1 version, which has the aggregation framework in it. It's just we don't consider it production ready until 2.2 is out. So give that a go. So, and the last step is scaling your application, right? What we just spoke about is building it pretty much on a single instance of a machine. Well, the way that you scale in MongoDB, there's pretty much two steps, and the first one is that the basic unit of deployment is something called a replica set. And in a replica set, you're going to have a single primary node where all the reads and where all the writes go into. Actually, all the reads and the writes go in there. And then you'll have some number of secondary nodes. And the secondary nodes are all taking asynchronous replication from the primary. So when you do this, then at query time, you can specify secondary OK. And if you do that, then what's going to happen is the application is going to automatically balance read queries across all of your secondaries. So if you add more secondaries, you get more read scale out of the box. Your application doesn't even need to do anything. The idea is that by adding more secondaries, you get more read scale. Now, it is asynchronous, so if they are in the same data center or on the same rack, well, then it could be a half-second delay or a 1-second delay or something like that. And if they're in different parts of the world, then it could be a larger delay. So that's the nice part about these, is that these replica sets can actually span multiple data centers. So if you need, for example, a fully consistent data set, then you're going to only want to query the primary, because the primary is going to be always guaranteed to be up to date. If as you're scaling, you're okay with data that has some sort of lag behind it, then you can query the secondaries. I think a good example, and you can do this at kind of application runtime, a good example is something like Wikipedia. And no, Wikipedia doesn't use Mongo, but if I'm a user querying Wikipedia, it doesn't matter if I see an article that's 5 minutes old. However, or 5 seconds or 2 seconds. However, if I am writing that article and updating it, then it's going to be important for me to see the updates and the changes that I just made. So in that case, I might have me read from the secondary, and you can, or read from the primary. And you can do that at query time. So the idea is that if you want more high availability and read scale, you add more secondaries. And the reason for that is obviously the read scale, right? The more secondaries you add, the more that your application is going to have to balance across. And this is done automatically. You don't have to do anything at your app level. In terms of high availability, if a primary is to go down, a secondary is going to automatically elect itself to be the new primary. And so it's a self-healing system here where, and then when the old one comes back, it will come back as a secondary. And replication is a much kind of longer, more in-depth conversation about MongoDB. But the key to know is that replica sets get you high availability and they get you read scale. What they don't get you is, what happens if your write throughput is so much that it overwhelms a single node? Or what happens if your data set is so large that it doesn't even fit on the confines of a single node? Well, for that, you need to use MongoDB range-based auto-sharding, and that's sort of a larger topic. But, we have webinars about that, so if you want to do some searching online, great. Also, our MongoDB Day conferences are a great way to learn about scaling your apps. So you can find more info at mongodb.org. And once again, if you would like to ask me questions, feel free. My email address is Kevin, K-E-V-I-N, at 10gen10gen.com. So that's Kevin at 10gen.com. Happy to answer any questions you might have that you don't want to ask over WebEx. So now I'm going to head over to the chat panel here, see if there are any questions. So someone asked, can you use Mongo with Memcache? So you absolutely can. However, MongoDB uses memory mapped files, and in many cases, even though it is an operational data store of record, it's so fast that people, some companies are using MongoDB as an intelligent cache on top of their relational database. So in many ways, it acts like a cache, and it is that fast. So you typically don't need to use something like memcache with it, because then you're pretty much caching something which acts like a cache. So yes, you can use memcache, but you don't need to. Someone asked, do you have Mongo available for easy deployment as a service on Amazon Web Services? So you can actually, if you're looking for hosted Mongo, we have two partners, and they are Mongo Lab and Mongo HQ. So if you're looking for just a hosted Mongo installation, you can get that. And then the other thing is we do have MongoDB builds, which are certified for use with Amazon Web Services. So you can grab one of those as well. If there are any other questions online, feel free to ask. Otherwise, once again, my email is Kevin, K-E-V-I-N, @10gen.com. Okay, so there's a question then of how is the data stored in MongoDB? So, so the way that the data is stored is we actually store the data as BSON, so a binary serialization of JSON on disk. So we store BSON on disk. And so the data is stored on disk in Mongo. The way it works is that for every collection in Mongo, we have a sub-level data structure called an extent. And the data files, the extents are what the data files are where the database is held. So when you first create a database, we're going to allocate a small data file for you. And then as that database increases in size, then we'll pre-allocate another one, which is twice as large. And then as that one grows, we'll pre-allocate another one, which is twice as large. And eventually then what happens is we will have basically 2 gigabytes. We max out at 2 gigabytes as far as these files, and we'll pre-allocate 2 gigabyte files for you over and over as your database grows. There was a question about, can I make the slides available? Absolutely. I'll make them available. So if you can email me, kevin@10gen.com, I am happy to send them to you. So are there any other questions? Okay, yeah, so as far as the 2 gigabyte files are both on the primaries and secondaries, yes, they are. So I mentioned our data files, they are replicated down. So the primaries and secondaries are actually always going to have a copy of the data. If you want to have the data that is to be spread out across multiple machines, then you use MongoDB range-based auto-sharding, which is going to do that. Question is, do we have Java library available for use? Yes, so we have actually, we support a very large number of language-specific drivers. So whether you develop in Java, or C++, or Ruby, or Python, something like that, we have 10gen supported drivers that you can download and use. One person asked if the presentation is recorded. Yes, it is. And another question is, how do you compare the performance of MongoDB over AWS data storage for big data? Well, I mean, I think that pretty much depends on the kinds of queries you're running. So MongoDB is really good at storing large amount, like very large data sets, and running thousands of queries per second across it. But it depends on the application specific as far as AWS data versus Mongo. As far as and someone asked if there's a good hands-on tutorial you'd recommend, I'd just get started by downloading it. It's the easiest. Honestly, I think that what we just talked about is a really good hands-on tutorial. Download the product, download Mongo, install it, takes 5 minutes, and then just start loading data with it. Just start loading data with it. And when I mean loading data, I actually mean going into the shell and creating data files. Going to the shell and loading data, querying it, creating indexes, etc. And the next level on top of that is, okay, so figure out then what's the application that you develop in the most, and hook up the driver for that and get started with that. So last question, there was one question about what kind of sharding capabilities does Mongo have. So MongoDB has range-based auto-sharding, and it's actually really great the way it works, but I would recommend that you do some searching for it or go to 10gen's website and look at some of the videos we've presented about it, because it's a larger topic here. So the question, and then one last question, which is, what is the largest Mongo cluster that we've run in terms of gigabytes/terabytes? At what point will Mongo fail to scale? I haven't seen it fail to scale yet. We have people running hundreds and hundreds of nodes in production on a single Mongo cluster, and definitely in the hundreds of terabytes ranges. I know we have people in hundreds of terabytes. I don't know if people are at petabyte scale yet with Mongo, but from the words of the mouth of our founder, if there's some sort of scaling issue under a petabyte, it's a bug. So we're designed to scale to huge data sets. All right, guys. Well, thank you very much. Like I said, Kevin at tengen.com, Kevin at 10gen.com is my email. Feel free to shoot me a message, and best of luck, and I hope you all enjoy the presentation. Okay, bye.